Hey everybody, this is Dr. Gray. I wanted to walk you through exam number 1, just to give you a kind of a way that you can approach this sort of thing. So here was your exam. It was a total of 25 questions. It's pretty straightforward and covered basically all the topics that we had. I don't think there was anything that was radically different. So I'm just going to go question by question and give you a little bit of an idea of the correct answer and how you solve this one. So question number 1 reads, using a meter stick, 4 students made the following measurements of the same piece of wire. So they got one piece of wire and measured it. They got 76.48 centimeters, 76.47 centimeters, 76.49 centimeters. Now, those 3 numbers, pretty darn close to one another, differing only by 1/100th of a centimeter. The actual length of the wire is 84.55 centimeters. Their results would best be considered accurate and precise, precise but not accurate, accurate but not precise, and neither precise nor accurate. Well, one thing that we can say is those numbers are very similar to one another. Their measurements were almost identical. They were very reproducible. However, the actual length of that piece of wire was almost 8 centimeters different. So they basically, you could look at this and say, if they were to do it again, they'd probably get something similar to that 76.49 centimeters. And so with that, it's safe to say that their results were precise because they were reproducible, but they were not at all accurate because they didn't end up with kind of the actual number. Okay, now the next question is, give the correct formula for aluminum sulfate. So for this question, we've got a compound of aluminum, or we've got aluminum and sulfate. So what's important to know about this is the sulfate ion has a charge of -2. So sulfate has a -2 charge, and aluminum is, or the common cation for aluminum is +3. And so if we were to, let's see, I'm going to annotate. So aluminum, Al +3 SO4 2 minus. One of the little tricks that you can do is take the superscripts and erase the sign, but keep the number, and then switch them. Rather than having them be superscripts, make them subscripts. So you would end up with 2 as the subscript for Al, and then SO4, your subscript for that would be 3. If you think about it as charges, well, you have 2 times +3, which is +6, and then 3 times -2, which is -6. So that would give us our compound that is neutral. And so that would end up with D as the correct answer. So I will clear all my drawings, stop my annotation, and highlight the correct answer, which is, oh, not that, D. Okay. Which of the following is the correct name of the compound FeO? The correct name is iron oxide. The tricky part about this is you have to know that oxygen is a -2 anion, and notice how there are no subscripts or superscripts or anything like that. So that means that we have 1 iron, 1 oxygen. In order for that to be true, you've got to have Fe2+ or iron 2 oxide. Which of the following is the correct name for the compound PCl5? Well, phosphorus and chlorine are both on the right-hand side of the periodic table, so they are both nonmetals. And if you look at that, you're going to say, well, as a pair of nonmetals, that is a molecular compound. Molecular compounds are where we're using coefficients. So you have to use a coefficient for that chlorine. You've got to use 5. And your coefficient to imply 5, or to say 5, is penta. So we've got pentachloride. Which options give us pentachloride? Well, we're really left with A and B. Now, the difference between these is that you have to remember the rules for your covalent compounds. And your rule is when you have a single atom, you do not use that coefficient. So you would not say monophosphorus pentachloride. Instead, you'd say phosphorus pentachloride. Next up, number 5, how many protons, neutrons, and electrons are in 40 Ar 3-? So argon with a 3- charge and 40 as our mass number. So our mass number is going to be our number of protons and neutrons combined. So you can look at answer option A, 40 protons. That one you can go ahead and cancel out because it's saying that your mass number is only protons. And it's, remember, your mass number is your number of protons plus your neutrons. So number 1 is out. Next up is 18 protons and 22 neutrons. Okay, well, those two numbers will add up to give us 40. So that's encouraging. Now, before we answer this, though, let's go ahead and look at that last part of it. 21 electrons. Okay, so if we have 18 protons, so that's 18 positives, and then we also have 21 negatives, 21 electrons, that means we're going to have more negatives, more electrons than we have protons. Therefore, we're going to end up with something that has a with a negative charge. In which case, B is a very appealing answer. Now let's go through C and D, though, just to make sure. C, we've got 3 protons, 22 neutrons. That would add up to 25. That's not right. Not to mention our number of protons, our mass number, that doesn't add up. Okay, now answer option D, protons plus neutrons. That means we've got 22 protons, 18 neutrons. So that would be 40. That would give us 40, but we have more protons than we have electrons. Therefore, our charge would be +3. So our answer for this is B. Next up is how many significant figures are in the number 1250.003? These 3 zeros are sandwiched between non-zero digits, in which case they are significant figures. We've got 4, 5, 6, 7. So our correct answer is B. An atom with 15 protons and 18 electrons. We have 15 positives, 18 negatives. We're talking about an anion, something that is negatively charged. The best name for the compound ClO4 is, well, this is just something that you kind of had to memorize, but this is all dealing with the halogenated oxyanions. We've got hypochlorite, chlorate, perchlorate, chloride. If you remember, perchlorate has 4 oxygens. Chlorate has 3 oxygens. Chlorite has 2 oxygens, and hypochlorite has 1 oxygen. This is ClO4, so we've got perchlorate as our correct answer. The best name for the compound MgCO is, well, we've got Mg, which is magnesium, not manganese. So answer option B is out. CO3, that's the carbonate ion. And so we've got magnesium carbonate is the correct answer for this. What is negative 18 degrees Fahrenheit in degrees Celsius? Select the best answer. For this one, the best thing to do is go ahead and do the annotation. We've got a formula, and our formula is degrees Celsius is equal to degrees Fahrenheit minus 32 times 5/9. Okay, now what we're trying to do is we're trying to solve for degrees Celsius. So we will go ahead and just plug in negative 18 minus 32 times 5/9. So that would be the same as negative 50 times 5/9, which you could look at that and say 5 times 50 is 250 divided by 9, and that would be, calculator, that would give us a correct answer of negative 27.7778, in which case our best answer is going to be negative 28. None of the other answers are really close enough. And so that's where that ends up. Okay, we've got this. Okay, so our correct answer is going to be that one right there. There we go. All right. Measurements indicate that 29.3% of the residents of a city with a population of 553,952 are college graduates. How many significant figures are in the correct answer? And you know what? This question, this is one that I think I'm just going to give credit for because I really didn't answer, or I didn't ask a question there. So this is question number 11. What I was getting at was basically asking you to look at the percentage here, 29.3%, and then say, well, if we're going to report how many college graduates of that 29 or of that total, how would we represent that? And the correct answer would be 3. So that one, number 11, I didn't write a good question, so I got to give everyone credit for that. Now, the next question, on the other hand, starts out the same way. 29.3% of residents of a city with a population of 553,952 are college graduates. This question is a fair and good question. How many college graduates live in this city? And what you need to take away from this is you need to take away that your answer should have 3 significant figures, which really eliminates answer options D and E. Now, that leaves you A, B, and C. So 1.62, the question is it times 7 times, times 10 to the 7th times 10 to the 5th, or is it times 10 to the negative 5th? Now, the way that I like to approach this is I like to say, is my exponent positive or negative? If it is negative, as is the case with answer option C, I'm looking at a very small number, something smaller than 1. If my exponent is positive, 1.62 times 10 to the 7th or 1.62 times 10 to the 5th, those two numbers have positive exponents. Now let's think about this. 29% of 500,000. We are looking at a number that's over 150,000. If we move a decimal place 7 times, 1, 2, 3, 4, 5, 6, 7, that is a large number. That is a larger number than what we started with. In which case, our correct answer would be times 10 to the negative 5th. So another way to think about this is I like to give myself let's draw out 1.62 times 10 to the 7th. Let's write that full number. 162, so that's move my decimal place 1, 2, 3, 4, 5, 6, 7. Okay, so 16,200,000. 29% of 500,000 is 16 million. Well, that's obviously wrong. So make sure you don't fall into a trap like that. So our best answer is 1.62 because of the correct number of significant figures, and times 10 to the 5th because it is a large number. Next up is 29.1 meters converted to kilometers. So 29.1 meters, well, there are 1,000 meters in 1 kilometer. So effectively what we could do is say 29.1 divided by 1,000 in order to answer that question. So what we would end up with is, nope, calculator. 29.1 divided by 1,000 is going to give us 0.00291. 0.0, sure of that, 0.0291. Okay, so this is smaller than 1, in which case this is kilometers. Those are my units. I can move my decimal place 1, 2. So 2.91 times 10 to the negative 2nd kilometers. Therefore, my correct answer is none other than, that's right, A. Okay. Go. Next up, titanium has a density of 4.55 grams per cubic centimeter or centimeters cubed. What is the mass of 150 milliliters of titanium? Select the best answer. Now this one deals with a unit conversion, but the good thing is 1 centimeter cubed is the same as 1 milliliter. So really all that we're doing is we're taking 4.55 and we're multiplying it by 150. 4.55 times 150, and our correct answer is 682.5. Well, 682.5 with the correct number of sig figs is going to be 683. So we'd highlight that one. All right, this next one, provided with the information shown below, what is the atomic weight of germanium? Here what we have are a total of 5 different abundances or 5 different isotopes and their masses. What we want to do with this is we want to say 0.028. Nope, that's wrong. Typo. There we go. 0.280. I can't write right now. Now I can. I can fix this. Okay. 0.208. Multiply that by 69.9242. Add to that 0.275 times 71.9221. Add to that 0.0775 times 72.9235. Add to that 0.363 times 73.9212. And then finally add to that 0.0765 times 75.9214. And that's what we get. Okay, so all that you need to do for this is punch all this information into a calculator, which I've got, 0.208 times 69.92. That gives me 14.544254.27. Oh, dang it. 0.275 times 71.9221. Oh, gosh. 0.9221. 19.77. 85775. 0.0775 times 72.9235. That gives us 5.65157125. 0.363 times 73.9212 is 26.833396. And then 0.0765 times 75.9214. And that adds up to be 5.807981. Okay, so I'll add all those numbers in. 14.544254 plus 19.778575 plus 5.65157125 plus 26.83333956 plus 5.807981, and I get 72.615. So I'll write that out. 2.61578, and there we go. Okay, so given that number, our best answer option is going to be, that's right, B. Okay, a lot of work involved in that and a lot of mistakes on my own end from calculating, but I think that it's helpful to write it all out so that you can keep track of your information. Clear my drawings and proceed to the next question. Okay, Now, what is the formula of the phosphate ion? The phosphate ion, we actually saw this earlier when we were looking at, didn't we? We saw sulfate, not phosphate. Okay, so that's different ion. Phosphate and sulfate are different from one another. They both have 4 oxygens, but phosphate has a 3- charge. Which of the following formulas contains the most hydrogen atoms? Well, this is asking you to think about when you see when you see subscripts and when you see parentheses. H2SO4, 2 hydrogens. Fe3OH, 3 hydrogens. We got a new candidate, new lead. Oh, but this NH4 and then in parentheses 2. So that means that parentheses 2 or that 2 applies to everything on the inside of the parentheses. So we got 2 nitrogens, we got 8 hydrogens. Okay, so we got 8 hydrogens compared to C3H6. So C is our winner. All right. Now this question right here and this question number 18 and 19, they are in the sequence of empirical formula and molecular formula. You're given a structural formula. Every atom is shown and the relative positioning of them is shown. So this one, you can kind of give yourself a little bit of help by just counting up the atoms with the lowest number. Oxygens, 1, 2, 3, 4. So we've got carbon, hydrogen, oxygen. We got 4 oxygens. Carbons, 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons. And then hydrogens, 1, 2, 3, 4, 5, 6. 6 hydrogens. There we go. C8H6O4. Okay. Now the question is, this is asking about an empirical formula. What is your empirical formula? That's your lowest common denominator. In which case, we are not looking for C8H6O4, but rather what we're looking for is reduce those down. What is our lowest common denominator? Well, you can divide each one of those by 2. You can't divide them any further than that because 3 is a prime number. You can't reduce 3 by anything but itself. So C4H3O2 is our correct answer. Now, I'm not going to erase this because the same formula applies to question number 19. Again, C8H6O4. Well, this is asking for the molecular formula, in which case we are looking at C8H6O4. There's 3 types of formulas. There's a structural, empirical, and molecular. And this gave us our structural formula, asked for our molecular and our empirical formula. Next up is how would you best classify the element Si, or silicon? Silicon is it's in that space between your metals and your non-metals. It is an example of a metalloid. We talked about silicon specifically. Silicon as a metalloid has properties of metals as well as properties of non-metals. Select the group to which the element Sr belongs. You need to know your periodic table or see your periodic table. And when you look at Sr on the periodic table, what you'll notice is that it is in group 2. It's in the 2nd row on the periodic table. So I'll highlight that. What is the polyatomic cation that we discussed in class? Okay, the key there is a cation. Are there many polyatomic anions? Yes, there are. But there's one polyatomic cation. Now, A and B are the answers that I thought that would be the most appealing. Ammonium is NH4+, so that is your polyatomic cation. What element has 52 protons? This is a matter of looking at the periodic table and just your general familiarity with it. What you should be looking for is the whole number 52. That's your number of protons. That's your atomic number. Whereas the other number, the one that has, for instance, with this tellurium, 127.60, that is the average atomic weight or the mass number. So 52 is your number of protons, and the correct answer is Te, or tellurium. Number 24, if a compound XC2H3O2 is formed between some element and acetate, what must the charge of X be for the compound to be neutral? Now, to answer this question correctly, you have to know that acetate has a charge of -1. Notice how there's no subscript for X, therefore the correct answer is +1 for X. There's only one of them present. Now, number 25, which subatomic particle has the lowest mass? Protons and neutrons, if you remember, those basically have the same mass, and electrons, by contrast, effectively have no mass to really be considered. So the correct answer is D, electrons. Well, that was exam number 1. I hope this is helpful to maybe identify where some of your strengths are so you can improve upon those, and then maybe some areas that you need to make some adjustments. All right, well, have a good one.